So acid-base indicators, also known as pH indicators, are substances which change color with pH.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course.
pH. They're usually weak acids or bases which, when dissolved in water, dissociate slightly and form ions. And so to determine the stoichiometric or equivalence point, we have to use indicators. And so the proton release, or H plus release, results in a structural change. And this structural change results in the absorption of light in a different manner. So as an example, let's look at any of these. For methyl orange, it starts out as a red color when it's in an acidic solution, and at a certain pH value, it changes color to yellow due to a structural change based on the addition of protons or the taking away of protons. It changes color. And looking at these different indicators, they change colors at different ranges. So depending on what kind of experiment you're doing, depending on what kind of acid, what kind of base you're using, you need to use a particular indicator that's going to change color in the correct range that you're interested in. So to write this out in a more general form, let's say you have a proton attached to an indicator, In, and you put it in water. It dissociates into a proton and an ion minus. So when we look at the equilibrium constant of the indicator, we can write it out as the concentration of H3O plus, ion minus, over HIN. So the end point, which is the point at which the colors change, so in this case, the end point is going to be here. For methyl red, the end point would be here. For bromothymol blue, it would be here, etc. The point at which the color change occurs is going to be the concentration of H indicator equal to the concentration of ion minus. And so K indicator at this point is going to equal the H3O plus concentration, because if this is equal to this, they cancel out and we end up with just this. So the color change occurs when pH equals pK indicator. We got this from taking the negative log of both sides. So a good indicator has an endpoint which is equal to the stoichiometric point. Equivalence point. And so when you choose what indicator you use an indicator with a pK indicator that is plus or minus 1 pH unit of the stoichiometric point or the equivalence point. So this is the same as the rule that we looked at before when we were talking about buffers, right? It has to be within 1 pH unit in order to be effective. So now that you know about how to do titrations, where you titrate a titrant, whether it's an acid or a base, with a sample, which is an acid or base, and then we can tell the point at which the number of moles of the base and acid are equal by making the pH curves. And now we also know how to get the endpoint, which is indicated by a color change based on these different indicators. And we also know the rules for how to determine which indicator to use based on this rule. So now to finish off, I'll show you how to do a titration calculation.